The next group is Kansas City, Missouri, Kansas, Team 1. This is grade 7.
Good morning, everyone. Our investigation, Biocides and Bacteria, was the Mission 6 flight experiment to the International Space Station for Kansas City, Missouri. I'm Nicole Ficklin, and this is my co-principal investigator, Eamon Shaw. Unfortunately, our third investigator, Holden O'Keefe, was not able to be here today.
Our investigation aimed to determine the effects of the antibacterial agent liquid iodine on Escherichia coli bacteria in microgravity as compared to on Earth. The experiment was conducted aboard the International Space Station with 2 controls on Earth. After analyzing our results, it was found that our hypothesis was proven. Antibacterial agents in microgravity are shown to be less effective, either as a result of a microgravity environment inhibiting antibacterial power or the greater resilience of bacteria in a microgravity environment.
If an outbreak of dangerous microbes was to occur on the ISS, it would need to be eliminated as quickly and completely as possible. Because of the substantial distance between Earth and the ISS, as well as the complicated and extensive process necessary to send anything to space, a fast-acting and effective antibacterial agent would need to be available. In addition, iodine is currently used by the United States to disinfect water aboard the ISS. For these reasons, we tested the effects of liquid iodine upon E. coli bacteria in microgravity.
Our hypothesis was that the E. coli would not be eliminated as well in microgravity as it would in the gravity of Earth. This is because microbes are known to reproduce faster in microgravity, and because of the fact that microbes in space are known to have evolved features, such as a structure never before seen on Earth, as well as more biomass.
The experiment was conducted using a Type 3 fluid mixing enclosure, or FME, that was separated into 3 volumes. Volume 1 held a mixture of rehydration medium and liquid iodine for the activation and elimination of the bacteria. Volume 2 held the freeze-dried E. coli, and Volume 3 held a glutaraldehyde solution, which acted as a fixative and inhibited bacterial growth at the conclusion of the experiment.
Clamp A, separating volumes A and B, was released 5 days before undocking, allowing the E. coli and liquid iodine to interact for 3 days' time. Clamp B was released 2 days before undocking, allowing the E. coli and glutaraldehyde to interact, inhibiting bacterial growth and terminating the experiment. 2 controls were conducted in conjunction with the one in microgravity, one containing iodine and one not containing iodine.
Once samples from all 3 FMEs were analyzed, it was determined that the control FME containing iodine had no living E. coli, the control FME without iodine had a great amount of bacterial growth, and the FME that was tested aboard the International Space Station contained far less living bacteria than the no iodine FME. The living bacteria observed here were deformed and were much smaller than the bacteria observed from the no iodine FME, but they were living nonetheless. This suggests that iodine is less effective in microgravity.
A possible reason for this could be that the antibacterial properties of iodine are not sufficient in microgravity, being that microbes are known to be more resilient in microgravity. Also, the substances aboard the ISS had less surface contact. On Earth, gravity would pull the substances together, allowing constant contact and elimination, while the opposite occurred in microgravity. As is the case with all scientific investigations, this was determined from the results of one test, and of course, more tests would need to be conducted to substantiate these findings.
Here's a look at a control sample after being conducted in gravity with no iodine. Many E. coli can be seen.
Here you can see the control sample after being performed in gravity with iodine. No E. coli can be seen.
And here is a look at the sample after being conducted in microgravity. Traces of E. coli can be seen, though very small and highly distorted.
Finally, we would like to thank our partners and sponsors for all of their support. We would also like to thank SpaceX for flying our experiment, and we would like to thank our teacher facilitator, Mr. Robert Jacobson, for giving us this opportunity. Thank you.
All right, let's thank the Kansas City group.